Hello everyone, welcome to TeKnowledGeek. Today we are going to discuss about the feed-forward neural network loss function calculation, and we will use different activation function at different layers, and then we will use the cross entropy loss function or the log loss function as our loss function to calculate the overall loss for that feed-forward network. We will use two hidden layers and one input layer and one output layer. We will initially discuss like what are the characteristics of a feed-forward network and why it is called a feed-forward network, and then we will show you all the mathematical calculations, and then we will calculate the loss at the end. So let's begin. Please watch till the end. Do you know what is the feed-forward neural network? It's the simplest form of the artificial neural network, and it is having the no cyclic connectivity between one layer to the another layer. Like no connection between the perceptron are cyclic in nature. It's always information is flowing in one direction from the input layer to the output layer. So there are certain characteristics of the feed-forward neural network. So it has the input layer to receive the input, and it has the output layer to give the outputs. So these are there are some perceptrons in each layer, and each perceptron is connected to all the perceptron in the next layer. And there are some layers in between the input and the output layer, so they are called the hidden layers because they are hidden from the outside world or the external world. And each layer will have an activation function. So that activation function will actually determine how to calculate the input. So input to each perceptron will be like the weighted sum of all the input, and then the activation function like softmax or the ReLU or the hyperbolic tan. So these activation function will determine the output of that particular perceptron. The characteristic of the feed-forward network is like there is no backward connectivity, like there is no feedback connection from one layer to the previous layer. And second is that no two perceptron of the same layer is connected. It's always connected to the next layer, all the perceptron. That's why the information flow in only one direction, and that's why it's named as the feed-forward neural network. So let's begin our calculation. I'll show you what feed-forward network I have taken, and then I'll show the calculation. So let's start on that. So now you have three different activation function at three different layers. Now I'll try to calculate all the values of each and every perceptron, what is the input and what will be the output. So as I have already discussed, so each perceptron things will be calculated as what is the input. If x1 and x2 is the input with the weight w1 and w2, so the input will be, so if this is my perceptron 1, so input to the perceptron 1 will be calculated as w1 x1 plus w2 x2, and output of this perceptron will be the activation function denoted as sigma of this input. So that will be calculated as sigma of w1 x1 plus w2 x2, and that activation function I just shown you that it could be ReLU, it could be TANH, it could be softmax. So now let's start our calculation. So I will just check the values from this sheet and I will calculate it in this sheet. So for the first layer perceptron, like the first layer is the hidden layer. So for H11, the input will be calculated as W1 X1 plus W3 X2. Now what's the value of W1 is 0.4 and X1 is again 0.4 plus W3 is 0.6 and X2 is 0.4. So it will be 0.4 in common, 0.4 plus 0.6. So it will be 1. So it is actually 0.4. H12 can be calculated as W2 X1 plus W4 X2. W2 is again 0.6 into 0.4 plus 0.4 into 0.4. The calculation will be same as previous, so I can easily write 0.4. So these are the input for the first hidden layer perceptrons. Now activation function. So activation function is equal to ReLU. ReLU means sigma can be calculated as sigma of H11 will be max of 0 and H11. So now you know H11 is equal to 0.4. So max of 0 and 0.4 will be 0.4. Similar way, sigma of H12 is equal to 0.4 only, because it is max of 0 and H12, and H12 is 0.4 only, so it will be 0.4. So now if I just write this value, so now this layer has the output value as 0.4 and 0.4. Now going to the next layer. For the next layer, like second hidden layer. So there, if the input is denoted as H21, then H21 is calculated as W5 into sigma of H11. So that is the output of the first hidden layer, plus W7 of into sigma H12. Now it is W5 is 0.6 into, for the first hidden layer, so this is my first hidden layer calculation, right? So now you know sigma of h12 is equal to 0.4 and sigma of h11 is equal to 0.4. So I'll just keep it like this. So 0.6 into 0.4 plus W7 is 0.7 into 0.4 is equal to 0.4, 0.6 plus 0.7 is equal to 0.4 into 1.3 is equal to 0.52. Similarly, H22 is calculated as W6 into sigma of H11 plus W8 into sigma of H12. So now W6 is again 0.7. Sigma of H11 is already we know 0.4 and W8 is 0.6 and then sigma H12 is equal to 0.4. So it's also same like 0.4 into 1.3 is equal to 0.52. Now activation function. Activation function of this layer is hyperbolic tan. So now we know hyperbolic tan of x is equal to e to the power x minus e to the power minus x by e to the power x plus e to the power minus x. So you can calculate it, or you can use some calculator which is readily available online. I'll just show you. So this is the kaysen.casio.com and you can calculate any activation function using this calculator. So I know for sigma of H21 is equal to e to the power 0.52 minus e to the power minus 0.52 by e to the power 0.52 plus e to the power 0.52. This will be, if we just put this value 0.52 here, you can get it like 0.4777, like approximately 0.48. Similarly, sigma of H22 is e to the power 0.52 minus e to the power minus 0.52, because it's also 0.52, right? Both are same, by e to the power 0.52 plus e to the power 0.52 with a minus sign, and it's also same 0.48. Now second hidden layer calculation is done. Now I will come to my output layer. So it will be calculated as same way. So output layer. For output layer, y1 is calculated as so this is my output layer, and y1 is calculated as W9 sigma of H21 plus W11 into sigma of H22 is equal to, now you know sigma of H21 is 0.48 and W9 is 0.8, W11 is 0.4, and again sigma of H22 is 0.48. So it will be 0.48 into 0.8 plus 0.4 is equal to 0.48 into 1.2. So if you calculate it, so it is calculated as 0.576. So now y2 is, as you know, W10 into sigma of H21 plus W12 sigma of H22. If we just calculate it, W10 is 0.4 into 0.48 plus 0.8 into 0.48. So it will be like 0.48 into 1.2 is equal to 0.576, same as previous. Now we need to go for the activation function. The activation function in this case is softmax, and softmax of x is calculated as, if x is a vector, like it has two values x1 and x2. Our case x1 and x2 is, it's y1 and y2, right? So it will be y1 and y2 if they are the input. Now sigma of y1 is equal to e to the power y1 by e to the power y1 plus e to the power y2. This will be e to the power, this is 0.576, so e to the power 0.576 by e to the power 0.576 plus e to the power 0.576. So both of them are same, so it will be just half, that means 0.5. Same way I can calculate sigma of y2 is equal to e to the power y2 by e to the power y1 plus e to the power y2. So that will be also 0.5. Now I will go for the loss function calculation. So calculation of loss, which is driven by the loss function cross entropy or log loss. So this is the cross entropy or log loss function. So now I will calculate log loss, that is L is equal to minus 1 by
n for all the nodes, that means I is equal to 1 to n. OI is the output. O is the output, actual output, and log of predicted output. So this is actual output and this is predicted output, plus one minus OI log of 1 minus predicted OI. So that is the log loss function. Now we know in our case what is OI. So OI is 1 in case of I is equal to 1 and O2 is equal to 0. So n is equal to 2 and O1 is equal to 1, O2 is equal to 0, and what is P of O1? That is sigma of Y1, that is half, and P of O2 is equal to sigma of Y2, so that is also half. So now in this function minus half, for I is equal to 1, it will be O1 is equal to 1 into log of 0.5 plus 1 minus 1 into log of 1 minus 0.5. Now the second one. So this is the first one. Second one plus 0 into log of 0.5 plus 1 minus 0 into log of 1 minus 0.5. Okay. So this is the formula. Now this sorry for that, this will be calculated, this is calculated, this will be 1 minus 1 is equal to 0, and this is multiplied by 0, this will also be 0, and this will again be calculated. So that will be minus half log 0.5 plus log 1 minus 0.5, right? So this will be half, and 1 minus 0.5 is again 0.5, so it is 2 into log 0.5, so that will be minus log of base exponential 0.5. So if you just go for the log table, so that will be 0.693. In other words, it will be 69.3% is the loss.
Thank you so much for watching this video. Please watch for more videos.